Good morning. Good morning, everybody. My name is Frits van Evert. I work at Wageningen University and Research in Wageningen, the Netherlands. And I'm also the coordinator of the Robs4Crops project. Robs4Crops is a new Horizon 2020 project. It's an innovation action, and it started on January the 1st of this year, and it will run for the next 4 years. Robs4Crops aims to develop an agricultural robotic system, which will in first instance be used for spraying and weeding, mechanical weeding, but it will eventually be used for a much wider range of tasks. Now, I don't need to tell you that crop protection requires a lot of labor. Often you may need something like 20 or 30 passes to keep the weeds and the pests under control in a single crop. And the work, and whether that is spraying, like in the pictures on the left and the bottom, or whether it's mechanical weeding in the pictures on the right and the top, it's often poorly paid work. It's also unpleasant, repetitive. It may be unhealthy, whether it's from pesticides floating through the air or from just simply dust. It may also require a lot of concentration to keep the tractor and the weeding tool aligned with the crop and not by accident start destroying the crop instead of the weeds. So it's a task that we would like to replace. And on top of that, all that, it's often migrant laborers that perform this work, and now with the pandemic, it's difficult to get these people to the place where they need to do the work. So there is a real imperative to replace this human labor with robots. Well, wouldn't it be nice if you can have robots that do all this work? And then they work the whole day, they trundle through the field up and down, and at the end of the day, when the sun sets, you go home and the robots continue to do the work. And in fact, in much of the economy, this is already happening. Robots are replacing lots of labor, but not so much in agriculture. And why not? There are commercial robots available for agriculture, like in the top left, the Robotics from our partner AgroIntelli. On the top right, the Seol robot from our partner Agriculture. They are there and they work, you can see that. But it turns out that in practice, there are still many issues that prevent the really widespread use of these robots. And Robs4Crops aims to achieve a number of technical aims and non-technical aims that must be met before robots will be used really in a wide way. So one of these things is to use existing standards whenever they are available. The 3.H, isobus, but also existing tractors, existing implements, existing farm management information systems or enterprise resource planning systems, depending on what domain you come from. Not all robots do that at the moment, and we think it's important that that starts happening. At the same time, we clearly also need to improve the state of the art in a number of areas. Obstacle detection, detection that something goes wrong. What happens when a weeder is going to the field and it catches, say, a broomstick or a stick or a mass of plants, and it fills up and it starts pulling down all the crop plants. When there's a person on a tractor, he can detect it. But when it's a robot, there's a chance that it will continue working and doing a lot of damage. And it also is necessary that these robots start doing a complete task, meaning move to the work field, perform the work, respond to all kinds of events that are rare but happen nevertheless, and then move back to storage. And in the non-technical area, farmers currently do not always have the information to decide whether a robot makes sense for them economically. Maybe it does, but this information is still not there. What happens with the data that are collected by robots? How do they affect the power relations between manufacturers, government, and farmers? Workers need to be trained in robotics. operating a robot is different than a tractor. There's some other issues also. As long as the economic impact is not clearly understood, it might not be so easy to get financing for a robot. Business models need to be looked at, and regulations, especially regarding safety and so on, needs to be clear to farmers. Are they complying with that when they buy and operate a robot? So from this, you can see that that there is a wide range of actors need to be involved to address these problems altogether. And so the 16 partners that we have in Robs4Crops are from 3 distinct groups. They are farmers and farmers representatives, cooperatives, and so on. They are machine and robot manufacturers, and they're academics. And they are going to work in this project in these 2 spheres that I have on this slide. On the left hand, the technical sphere, we'll be working on autonomous vehicles, on smart implements, and on software to control everything. And we'll be making use of existing stuff that is shown outside the circles, the robots, the tractors, implements, the standards, and so on. And on the right-hand side, we have the non-technical work that mainly involves a whole bunch of different stakeholders, and where we will develop protocols and information flows to make sure that that these things run smoothly. And these 2 spheres, they meet in the large-scale pilots. And the large-scale pilots are simply commercial farms where the technical solutions will be demonstrated and evaluated also in the context of the non-technical users. So let me take you to a bunch of these parts of the project. So the first thing on the technical side is the smart implements. I already mentioned that if a weeder is going to the field, you need to basically constantly check whether it's working correctly or not. Are the tines still rotating? If there's tines on the thing, are they working at the correct depth, and so on. For a sprayer, you might want to monitor whether there's enough liquid still, whether the nozzles are functioning, whether the pressure is right, and so on. And all this information needs to be collected, for example, with cameras, but perhaps also with other sensors, and then sent to the control software. The vehicles, I mentioned already, we'll be using both the Robotics and the sail robot, but we will also be using tractors, conventional tractors, which are retrofitted to make and behave like an autonomous vehicle. The reason for that is that this will allow farmers to use their current investment in this kind of machinery without having to toss that basically and buy a completely new thing. It would also make it possible to, for example, climb on a tractor and move it to a place that it might not be able to reach autonomously. And so we see this as an important stepping stone from where we are, regular work, conventional work, to a fully automated system. Then we want to go clearly beyond just autonomous vehicles and implements, because the project will also put a farming controller layer on top of this, and in order to make a complete robotic system. So for that, we will describe the resources and conditions that are necessary to complete each task. We'll write software that plans and schedules and orchestrate these tasks by matching resources to goals, by preparing the work, performing the work, and to respond to events that might happen while you're working. When you're reading and it starts raining, for example, it's probably better to stop and go home. And when you're spraying and the wind picks up, again, it's time to stop. We'll be using digital twin technology in this area to explore alternative responses to events that happen by simulating the effects of these different responses and then choosing the most appropriate one. So that's for the technical side. Now we move to the non-technical side. We have commercial farms in 4 countries. They're listed here with a range of crops. And we'll be demonstrating the robotic system under basically real-world operation conditions. Real-world, both in terms of commercial size farm equipment and the people that operate it. In the beginning of the project will be the academics, if you want, or the manufacturers. But towards the end of the project, it will be more and more the local laborers. And we're working in these large-scale pilots with a wide range of stakeholders. We will also be looking closely at the socio-economic aspects of using robotic farming. So, for example, well, the first thing that we need to know is what is exactly the cost and what are the benefits, and is it a net benefit or not? So we'll be collecting data to enable us to make these calculations, and it will present them in a web-based planning tool to farmers. And an example of how that might look like is shown in the figure on the right. This is work done by our partner from University of Copenhagen. This particular example is for precision agriculture, various systems. And it relates to farm size. So it shows that on bigger farms, these things are more useful than on smaller farms. Maybe this is true for robotics too. Maybe it's different. Anyway, we'll be also considering the impact on employment. Of course, the whole purpose of the project is to replace this poorly paid, unpleasant, unhealthy labor with robots. But what will be the consequences of that then in terms for people? Will there be other jobs that crop up? Will there be other opportunities? This is something that will be charted by the project. Then also in terms of data ethics, I mentioned already that collecting lots of data and making those available in different ways could affect the power relations between the various stakeholders, and we want to be on top of that. Then a farmer could go out and buy a robot or a robotic system and own it. But we will also look at alternative forms of using the robotic system. That could be through some form of shared ownership, renting, or sharing it between 2 or more farmers, perhaps in a form of a cooperative. This is quite common in France, and they have a special name for it. They call it pumas. But of course, also farm contracting is a usual way of deploying expensive equipment. Common is the way where you charge for treatment, but there's also a new development going on now where farmers make service contracts with contractors. So to keep my field free of weeds for the entire season for a fixed amount of money, or do all the crop protection that's needed, whatever. So we'll explore the opportunities for that in terms of robotics. Okay, then my final 3 slides will be about how our project will reach out to outside the project, to partners, to parties outside the project, both during the lifetime and after the lifetime of the project. And an important part here will be played by the digital innovation hubs, the one-stop shops that are set up by the Smart Agri hubs and the Agro Food projects throughout Europe. And I'm sure that most of you have come across this. But basically the idea is that if you have a question about robotics or any other topic, you can go to this place and get both technical and non-technical assistance or contacts with people that can help you with that. So that's a very good mechanism. And it helps, of course, that both Smart Agri Hubs, Agro Food, and Robs4Crops are coordinated by people from Wageningen University and Research. So the links are very direct there. Also, Robs4Crops partners lead 3 of the regional clusters in the Agro Food project. Erik Pekkerit from our own organization for Northwestern Europe, Jesus from Euricat for Portugal and Spain, and Michael Koutsiaras from Athens for the Eastern Mediterranean. Another way for the project to interact with people outside the project is large-scale pilots, sorry. So we'll be doing demonstrations there, and we'll certainly invite all kinds of parties to come and watch. That's a great opportunity to have a dialogue with stakeholders and potential new partners. And I think it might also could lead to new collaborations. I could well imagine a machine manufacturer that is not in the project that sees our robotic system and says, hey, I want to try my implement with your, or match my implement to your robotic system. What's needed for that? That could lead to a new project. So in short, basically our project will produce a number of reusable assets, data sets, knowledge, software, economic tools, business models, and so on. And in principle, we want to have a large impact by sharing these things. And we're currently working on identifying a framework which will allow us to share these reusable assets to the DIHs and so on, but in a way that meets the IP, the intellectual property, and the commercial needs of our partners. So if you have any ideas about this, mechanisms for sharing this, or particular parts of the project that you think might be of interest, let us know through the website or through contact with me or any other means. So let me finish by putting up this slide with the logos of our partners. As I said, 16 partners from a wide range of kinds of stakeholder groups, and I'm very happy to have them. So thank you for your attention, and if there's any time left, I will try to answer a few questions. I think I need to pick up the questions here from the chat box. What is the relation between virtual and real robotics? Not quite sure what's meant by that question. Maybe it relates to the digital twin technology slide that I put up. So basically, in the digital twin technology, we make a model of the farm and the robots that are operating on that, and so we can simulate. We can say, robot, go do this field first at this speed and use this implement, and then we'll see how long it takes that work, for example, if it runs into any obstacles. But we can also, at the same time, we can simulate in the computer another course of action. Maybe do the other field first, or whatever. And by simulating all those things very quickly together, we can see which course of action gives the best outcome, and then we can choose that one. So the robot gets stuck in the field with an obstacle. It cannot continue in a particular lane because somebody left a cube crate, apples in the lane. We can simulate, is it better to go back and go to the next field, or is it better to back out of the field and go to the next lane, or whatever. And then based on that, it can take the most appropriate action. That's what the digital twin does. Another question is, how will we handle the topic of labor replacement worries for seasonal workers? Yeah. If I knew the answers to that, we wouldn't need to have that part of the project anymore. It's clear we aim to replace part of the seasonal labor for economic reasons, and it's cheaper, and it's a fairly large outlay for farmers at the moment, labor. It's also there's some uncertainties around it. It's you know that in the long term, the people that come from that are migrant laborers now, that they want to stay home and have better paying jobs at home, close to the families. Nobody really wants to do migrant labor. So in the long term, it needs to be replaced, but in the short term, yeah, you're right. It will displace some people, and we will chart that and see if we can, yeah, at least understand what's going on. And then based on that, once you understand it, it's probably in a better position to come up with ways of responding to that.
Sorry to interrupt, the presentation is finished. If you have any question, go on Agro Food booth, and then Frits will answer your question. Thank you.
Thank you for your attention.